Hi all, myself Misha Abraham, working as blockchain developer in Robert Bosch India in Innovations Group. I'm here to present on the paper Decision Framework and Detailed Analysis on Privacy Preserving Smart Contract for Enterprise Blockchain Applications. I have submitted this paper along with my colleague Krishnan Mohan. The agenda for today's presentation include a brief introduction on security, confidentiality and privacy, the need for security, confidentiality and privacy in blockchain, techniques and frameworks to address smart contract privacy and confidentiality, problem statement and proposed solution, literature survey, our proposed methodology, which is a decision framework, results and analysis, future work, and summary. Now let's go into a brief intro on security, confidentiality, and privacy. So the first one is security. A system is said to be secure if it is capable to prevent unauthorized modification and access of information. The second one is confidentiality. Confidentiality means that protecting sensitive data from being accessed by unauthorized parties. And the last one is privacy. Privacy means that ensuring that the data shared by the users is only used for its intended purpose. The main difference between confidentiality and privacy is that confidentiality deals with sensitive data which is of any kind, whereas privacy deals with data that belongs to a particular person, which is like a personalized data. There are many ways in achieving privacy and confidentiality in smart contracts. The different techniques for the same include software-based techniques and hardware-based techniques. Zero knowledge proofs, multi-party computation, homomorphic encryption are some of the software-based techniques. Trusted execution environment is the most prominent hardware-based technique. Why exactly security, confidentiality, and privacy is required in blockchain? So, in a blockchain technology, all the transactions are visible to all the members in the network. So, this is the exact reason why security, confidentiality, and privacy is very important in this particular technology. Let's go a little more deeper into the blockchain technology stack. So, from the bottom layer, we have the infrastructure layer. So, the infrastructure layer consists of infrastructures to operate the nodes in the blockchain network, like the storage, network, virtualization, etc. The next layer is the network and the protocol layer. It consists of network participation requirement, base protocol like Bitcoin and Ethereum, and methods for consensus, which include proof of stake, proof of work, COSIP protocol, Byzantine fault tolerant, etc. The next layer is the services layer. The services layer include the blockchain services to enable operation of the application and connection to other technology. Some of the services include multi-signature, oracles, wallets, digital assets, digital identity, distributed databases, smart contracts, distributed file stores, etc. The last and the topmost layer is the application layer. It includes the customer interaction, business logic, and user interface design. The levels at which security, confidentiality, and privacy is required includes the service layer. For example, the smart contract in the service layer. Smart contract is stored in all the nodes and it is executed by all the nodes. So it is very important to maintain security, confidentiality, and privacy. The next is at the storage layer, which is in the infrastructure layer. The storage in blockchain can be on-chain and off-chain. On-chain means that the data is stored within the blockchain, and off-chain means that it is stored somewhere outside, but the hash of it is stored within the blockchain. So it can be actually used or accessed whenever needed. Whether the data is stored on-chain or off-chain, security, confidentiality, and privacy is very important. Now let's go into the network layer. A network consists of many nodes which act like the members of the network. So in each node, security, confidentiality, and privacy is very important. In this paper, we will be addressing privacy and confidentiality in smart contracts. The techniques and frameworks available to address smart contract, privacy and confidentiality, and many, out of which we have chosen four frameworks, which are Equirin, Enigma, Bulletproof, and Hawk. Equirin is a hardware-based protocol that aims at bringing scalability and confidentiality characteristics to smart contracts and blockchain. Enigma is a decentralized computation platform capable of preserving privacy. Bullet proofs are zero knowledge proofs to build confidentiality in non-trusted setup, whereas Hawk is a framework developed to bring in privacy in smart contracts. What is the problem that we are trying to solve? There are too many frameworks available addressing privacy and confidentiality in smart contracts, because of which a customer with a particular business requirement is confused on which particular framework to choose to address the privacy and confidentiality problem. Second one is, what is the best possible framework for a given business use case? So our proposed solution includes two phases. So one in which we have given a detailed comparison of the various techniques, including software-based techniques and hardware-based techniques. The second solution include a proposed decision framework to choose between the techniques based on the business use case. Let's deep dive into the frameworks that we have chosen for our paper. So the first one is Ethereum. The main focus of the protocol is to develop a trusted platform for blockchain using trusted execution environments, and they have used Intel software card extension for the same. It is able to provide integrity and confidentiality. Apart from the same, it can also provide proofs for correctness of computation. So the below diagram says that we have a confidential data, and the computation of the confidential data is performed in the secure enclave within the Intel software card extension. Since the computation is performed in the secure environment, applications, operating systems, or even users cannot access the data or the confidential information. Thus, it is capable of providing integrity and confidentiality. Apart from that, it also generates a proof of correctness of the computation which can be validated by another third party. The second framework is the Enigma framework. The computations of the system are performed both in the blockchain and also in Enigma within Enigma framework. Enigma handles computation of transactions which requires privacy and ensures both privacy and correctness of the execution. The proof of execution is stored in the blockchain and can be validated by participants in the network. The diagram below shows that the public data is handled by the blockchain and the private data is handled by the Enigma, and the encrypted data along with the proof of computation is stored within the blockchain, which can be validated by any member in the network. The third framework that we have chosen is the Bulletproof, which is a protocol that leverages non-interactive zero knowledge using the Fiat-Shermer heuristic concept to build very short proofs. It is also known to work efficiently in the field of range proofs. It means that it can be used to prove that a committed value is within a range. So the diagram says that Peggy have C1, C2, C3, which are the commitments to be proved that they belongs to a particular range. For that, using bulletproof, Peggy have to create a proof which can be validated by Victor to check if that C1, C2, C3 belongs to that particular range. How bulletproof is different from normal range proof is that for C1, C2, C3 commitments, Peggy have to create only one particular proof, whereas in normal range proof, Peggy have to create three proofs to prove that C1, C2, C3 belongs to a particular range. This actually reduces the size of the proof that need to be sent to the other party. The last framework is Hawk framework. Similar to Enigma protocol, a Hawk program is separated out into two sections, one containing private details and the other containing public details. The private portion helps in maintaining privacy in user data and exchange of money. The public portion does not deal with confidential data or money. So our proposed methodology is a decision framework to choose the best framework for a particular business requirement. So how can this decision framework can be used is that by asking questions. So let's give it a try. Is multi-party transaction required for a given business use case? If it is a yes, is blockchain technology needed? If it is a yes, is privacy and confidentiality required? If it is a yes, then this is the exact place that you have to come in and find the best solution to bring in privacy and confidentiality. Now, again, do you need runtime privacy or storage privacy? If both the privacies are not required, you can go for traditional privacy preserving model. If runtime privacy is required and persistence is required, software based techniques is the best solution. So, in the framework that we have chosen, we have an example which is bulletproof, which is a zero knowledge proof. If persistence is not required, hardware based technique will give you a solution. Akron, which uses Intel SGX, is one such example. If storage privacy is required and trusted third party is possible, then you can choose between Enigma and Hawk based on the priority. If the priority is on scalability, integrity, availability, or correctness in execution, you can go for Enigma. Or if the priority is on contractual security, Hawk is the solution. If trusted third party is not possible, Bulletproof is the framework that you have to choose. Some of the observations that we have come out include Intel XGS is the most mature hardware based technology in this space. Zero knowledge proof based techniques are being adopted mostly in the blockchain enterprise networks. Homomorphic encryption is another evolving technique to address confidentiality needs. In our results and analysis, we have given a comparison based on data flow model and based on the parameters the frameworks could support. The data flow model include source, injection, pre-processing, execution, post-processing, and storage. Bulletproof is a framework that could provide privacy and confidentiality within the storage and execution part of the data flow model. Enigma and Hawk can provide privacy and confidentiality within the storage part of the data flow model. And Equinum as a framework which could provide privacy and confidentiality within the execution part of the data flow model. The next comparison is based on the parameters the framework could support. The parameters that we have chosen are integrity, availability, privacy, persistence, performance, correctness in execution, and scalability. A detailed description on how these parameters could be achieved by each of the framework is explained in our paper. This is an interesting slide for us wherein we come up with our future work. So the first one is testbed. Our aim is to develop a test network to compare efficiency of the techniques discussed in the previous slides. The next one is on zero knowledge proof, a practical evaluation of the SID-KB techniques in blockchain networks. And the last one is on the homomorphic encryption. Evaluation of fully and partial homomorphic encryption is also one of the interesting area for us. In this paper, we analyzed the existing privacy-preserving techniques for smart contracts and proposed a decision framework to choose among the techniques based on business needs. The decision framework that we have proposed is useful for blockchain architects, network operators, etc. for framework decision. In the enterprise blockchain space, security, confidentiality, and privacy is one of the significant adoption barrier for blockchain networks. And this paper is the right resource for getting a heuristic view of the various techniques available in the market. Thanks for watching my presentation. Stay safe and take care.